This is Milani, Chapter 15, Section 1. Before I go over next problem, I would like to go over one of the simple basic math. If I have a over b, then divide it to the c over d. This is the complex fraction, which the way the book it says, we have to write it down a over b, and this line is become division sign, and d over c over d, that's going to be my second fraction. Then change the division to multiplication. Then the first fraction, write it down as is. Division is become multiplication, but your second fraction is become reciprocal. Then I have a multiplication of a two fraction, which your numerator you multiply by each other, a times d. Denominator you multiply by each other, b times c. Now, this is the book way is, but I'm going to show you the shortcut, which this shortcut is going to help us a lot for the next problem. On this one, my shortcut is going to be, anytime you have a one fraction in the numerator, one fraction in the denominator, then you will multiply the outside by each other, a times d. It goes as a numerator. You multiply the inside by each other, b times c. That's going to be. That means from here, my shortcut, you can just jump to this one. Now, keep this one in mind. Now, let's go with problem number 8. The first thing we do, get rid of the radical sign. Rewrite it as a rational exponent. Remember, antiderivative, we do not have any quotient rule, chain rule, or product rule. Here, I have a x times x to exponent 1/2. We do not have a product rule, but we can use the law of the exponent. Anytime the base is the same, then you will add the exponent by each other. That means 1 plus 1/2, which is going to be exponent 3/2. Now, I do not have a product rule. I have two simple terms, which you are going to write it down your coefficient. X to the exponent 3/2, you add a 1 to the exponent, which is 5 over 2, and the exponent, it goes as a denominator. The same as next term, minus 3, I just carry it down. X to the exponent 1 over 2 plus 1 is become x to the exponent 3/2. Exponent, it goes as a denominator, c. Now, from here, I have a complex fraction, but let's write it down this and this, the both numerator, let's write it down over 1. This way, we can see our complex fraction, which we go by my shortcut. We multiply the outside by each other. It goes as a numerator, which is going to be 2x to the exponent 5 over 2 times 2. I'm going to first leave it as a multiplication. I would not multiply it by each other. The same as here. 3, this parenthesis is going to be times this 2. But remember, it doesn't matter if this 2 is going to be inside here or the outside. It doesn't matter. And then 1 times 3 is going to be 3. Then, simplify. 2 times 2 is going to be 4. Right here, This 3 I can reduce. That would be my final answer. Now, I do have again, sometimes I do have my own shortcut. I would mention to my student, and then if my student like it, you are going to get it. If you do not like it, then stay with the book way. Now, with my shortcut, from here, I can just jump to this, but pay attention to it. From here, these 2, I carry it down. Then, x to the exponent, as a matter of fact, this part, I'm going to show it right here. These 2, I carry it down. Then, x to the exponent 3 over 2, you add the 1 to it, which is become x to the exponent 5 over 2, and then reciprocal of a 5 over 2 is going to be 2 over 5. 2, it goes as a numerator, 5, it goes as a denominator. If you pay attention to this, you can see it is exactly the same as this. Now, let's go with this. This minus 3, carry it down, which is this minus and 3. Now, x to the exponent 1/2 plus 1 is going to be x to the exponent 3/2. Reciprocal of a 3/2 is going to be 2 over 3. 2, it goes as a numerator, 3 is denominator, and that's the one you will see it right here. Then, and don't forget, of course, plus C. Your choice. You can go by the book way, which is going to be this, or from here, you can just jump to this by my shortcut, and that is going to be the answer.